this part we're going to do unwrapping and texturing of the model. To start with, I have here my screen and a tank model, and I also duplicated the tank, and I don't want individual UVs for every tank. So if I have 5 tanks, they all share the same UVs. So what I will be doing is I will be unwrapping this null node here, and then they are then copied and then referenced back. So with this null node, I will combine the other null nodes and the other ones. I will also create here a null node for the frame, out frame, and also here for these pieces. We can also unwrap one piece. So in here, I'm also going to place a null node out support piece. And I will be unwrapping these null nodes. So I'll create a network here on the side where I object merge these together. So I would like to have the out from my tank. So one tank model. Then I would like to have the screen. Then I would take the, and then also the support piece. This. So these are the pieces that will be uniquely unwrapped. So if I would combine them, they are looking like this, and these will then have unique UVs. You could take it a step further and, for example, cut the support frame in half because they are symmetry. So I can, for example, do this. So only unwrap one side, and then we can flip the UVs then on the other side. So that's also a possibility that we could do. So the downside of this is, of course, that it can be noticeable that we have done this, that the texturing will be the same. So the idea is here that we create a UV here, so we can auto unwrap it. So as you can see here, we have the unwrap. You can check out the other unwrapping features and play around with settings to what you prefer. Most of the time I prefer to use the unwrapping mode. And then this is the result. What could also be useful is that each piece has an ID number. So I'm going to create an attribute and I'm going to give them an ID. I'm also going to bypass the UVs for now because it can take some time to calculate, and I will be first adding some ID numbers. So I'm going to call it ID index, for example. And this is number 1. So my tank is number 1, my screen is number 2, the frame is number 3, and then the support piece is number 4. Something like this, so we can access each individual piece if we want to. I also want to make sure that if I would take information that they're not overlapping. So what I could do is I can do a for each named primitive. So they will be based on attributes, and we're gonna loop on them based on the ID attributes. ID index. So one small thing is I actually stored the ID index in points. So I'm gonna select all the ID nodes and I'm gonna store them then in primitive. So we can actually here loop on ID number. So we can control what piece is going to be looped first. So if I would single pass the loop, we can see that my tank is loop 1, the screen 2, and so on. So they are in the exact order as I created them here. So they are controlled. So what I would like to do is that I would like to transform them every loop a bit more. So I will be using the iteration number. So we have to create this extra node, and this stores the iteration number. And in here, I can ask that iteration number. So I'm going to type in detail, and then I ask the for loop, the metadata for the iteration number. So what you would fill in is look something like this. So we want to ask the details of the for each begin metadata, and we would like to have the number of iterations. So they have actually moved, as you can see here, but we need to have them further from each other. So I will be, for example, multiplying a value in here. So let's say 5. That should be enough. So they have enough spacing too big separately. Then I would start creating the high poly. So if you have seen the other videos of the Sci-fi series, you know that I'm going to use a voxel to create a high poly. So in here as well, I'm going to use the voxel node. I'm going to use it in the loop to create high polys. So what first I'd like to do also is disable the bounding box, because it will automatically decide how many voxels. Enabling the bounding box relative will scale your model, so every loop has maybe a different density. And let's start out with 0.1. And let's see how many polygons we have right now. So we have almost 2 million polygons. Also on the tank model, if you would go back, I have in here where we created this outer shell, I have closed this output because it works better in the voxel. And there are a few more cases where some parts are not that nicely done. So also here I had buttons on the side here, and also this piece has this really weird things going on. Now to fix this quickly, we can use a polyfill node, and that should help with some parts. As you can see, it already works by just plugging it in there. So my buttons are back, and also this shape is way more cleaner. But I prefer to also have it here in single polygons, and I'm also in here in the voxel. I would also like to have some smoothing, because right now everything is hard edged, and I would like to have some smoothing. Then after this voxel, I would like to assign that attribute again, the ID number. So if I would go back and create that attribute number based on the iteration here. So I'm going to copy this piece and paste it then in the value. Of course, I have to remove the multiply by 5. And I'm also going to do +1 because the loop starts with 0 and my first number should be 1. Then I will also use the same name here again, ID index, and also store it in the primitive as well as I did before. What I can also note is that this tank is not that nice and high poly. It sort of like took the low poly and made it like a little bit smoother, but you can still feel the low poly in there. So ideally I'm gonna increase the amount of divisions used in this tank. So I will go up here, and I will be increasing this columns. And because of the procedural way everything is structured, I can easily fill in here bigger numbers. So I hope 100 or maybe 120 should be enough to create a nice high poly feel. Also here for these pieces and the pipe, I'm also going to go over here and start increasing these numbers so they have a smoother surface. Same for these pieces, I'm going to increase them. So if I will go back here to my loop and let everything calculate, it's now going to be smoother. I'm still not that happy with this result, so we might have to go way higher than I was planning. So I have increased the values and I'm more happier with this result. This can then be used for my high poly. We can also create a color map and some edge damage like I did in the videos before. But for now, let's focus on just the normal map. And let's create the maps baker. So I already have my high poly, and now I would like to construct my low poly. And for my low poly, maybe I want to keep using most of these nodes except for the tank, because I had to increase the amount of divisions here. So what we could actually do now is I can start pole reducing this tank here. And because I have numbered everything with an ID index, I can now start asking which ID index I would like to have. So now I can filter out this specific model, in my case the tank, so I can filter this one out, and I can pole reduce this version, and I can say a specific number that I would like to have in this model. So in this case, we are using exactly 1000 polygons, but that might be too low, as you can see. So Let's start with 2500, and that already looks better. So this could be usable depending on how much polygons you would like to spend. Maybe in my case I go a little bit more higher, so we have this result then. And then here I will do the same then for my low poly, and I will filter out the tank. So I have these other models, and I could also use that for loop that I did here, and with the nodes. So I'm doing the same system. So I'm going to fill in here the ID index number. So it's going to loop over that, and then also I would like to transform that based on the information. So now they should be in the same position as here and here. You can also notice a mistake that the polyfill is actually getting in conflict with my system. So instead of doing this before, I might just do it in the loop. So right before the voxel. So it might sometimes throw a warning, say that there is nothing to fill. So that would be no problem normally. So now if we can compare the low with the high, we can see that they are on the exact same positions. So this is then my low poly that I can simply merge together. And this will then be using the UVs again. So again, you have to play around with some of these settings and find what you like the most. So but I'm in my case using the unwrap method. And then we have something looks like this. And we need to use the soften normals. And I will be using the hard seams. So this is then the low poly. I can also start dividing the low poly just so they are triangulized. And this is then the low, and this is then the high. So this is then ready for baking. So we can also go in the asset menu and include this baking settings in the digital asset. So we're going to create a new folder for the baker. So baker, and we can drag and drop whatever we would like to have. So I would like to have that button for baking. I would like to know where I would save it, the resolution, the trace normal, the ray distance, and I would like to have my normal map. So applying this, so we can in Unity access baking options to bake this automatically. So that is set up as well. In previous videos, I also used the vertex color to bake out different masks and use these masks in a Unity shader. And I've used this before in the grate generator and the door generator. One of these videos has information about creating multiple masks used in the shaders. Now I would like to have my low poly back on the original place, as you can see here. And we will basically doing this loop again, but reversing it. We can copy paste this loop, and I'm gonna reverse it. So in this code, we're gonna also multiply with -1, and then they should be back in the original space, as you could see. Then we can export here null nodes based on also the attributes. So I will be blasting away. So I've actually done this before here with the tanker. So I'm gonna copy paste this part and place it in here. So this one is the tank. Then this should be the screen. Yes. Then this is the frame. And then the last one was that small support piece. So they're all there. Then I would use a null node and call it out tank with UVs. And I will be doing then the same here as well. Out screen with UVs here as well. Out frame. So these are then the pieces with UVs included. So for the screens, the way I'm gonna switch from model with no UVs with UVs is here. I'm gonna create a switch node and I can switch between these two versions. So I've also in here made a toggle called UVs. So I enable or disable UVing. So if there is no UV, it works a bit faster. So then I have here my screens. And then I fill in the channel that goes to my UVs. Then I will be using the other node and will be using screen with UVs, so I can switch between UVs and no UVs. I will copy the switch node and I will be using the same here for the frame. So I had a frame with no UVs and now I have one with UVs. So I will go back here and look for frame with UVs. And I've also need to symmetrize it back in the original shapes and forms like that. And for the tank and the support pieces, it will be a little bit different. So we have to go in the network over here. And we basically have to do the switch here after this null node. So I'm gonna copy paste this switch node I have. And then here, again, using the object merge nodes. And in there, we're gonna decide which one we should take. So tank with UVs. And then here as well, if I go here to that support piece, I should also copy paste the switch here as well. So we could also here have the updated version. So that should be in place. What's also could be important here is that we don't override the normals anymore. And I'm gonna copy paste this away. If you would still have error in game engine where parts don't have normals, you can always go, for example, back here and then add a normal on top of that null node. So then we have this result, and let's go back here and enable UVs. We don't really see anything, and I would like to use the visualizer, the UV visualizer, so we can check out our UVs. And I can see everything is unwrapped okay, except for that outer shell. I didn't unwrap that one. And this was the outer shell. I'm gonna use here a simple flatten unwrap. So UV flatten. And when plugging this in and going to the UV space, you can see that it automatically unfolds and flattens the UV shells. So in this case, with the simple shape, it has a nice result that I'm looking for. So in my case, it can actually use the whole space, and I will be storing this in a different material ID. So how can we create different material IDs? A very easy way to do this is by just using a quick material. So in this quick material, it's automatically going to have the standard material properties set up. Otherwise, you have to create this material network and also these material nodes. But as this is already built in, everything is done for you. So then we plug these nodes in here. And this is then a different material ID. We can also give it some color to have a better visualization. So you could build in more material IDs based on what you would like to have. Now everything has an unwrap. So one thing I did not talk about is also the screen and the keyboard that I've put here. We're gonna also use a material ID for that, and we're gonna have to unwrap this in another way. So the keyboard is the easiest one. So this is my keyboard, and I'm gonna use the UV projector, and I'm gonna project the UVs, and I'm gonna click on initialize. So it's automatically searching for a nice fit. And here I'm gonna use a quick shade, and I'm gonna load my Sci-fi texture. So I loaded my texture that I would like to have. So at the top I have space for my screen, and at the bottom I have a keyboard. So now I'm just gonna rotate this in the correct position, and I'm gonna reset this to 1, 1, 1, and I'm just gonna move it in the correct position and scale it also. So this is then my keyboard. So then here, this other part is then for my screen. Now we would like to have this information about my screen, these primitives. And actually we already know this information because I used it in these extrude groups. So if I quickly take a color node here, for example, and I would color the extrude front group, and I will be using a color, we can already see that the part where my screen is already colored. I use this to build up the screen. So in here, what I will be doing, I will be using a UV project as well. And I'm also going to put in the quick shade to visualize it. And in here, I can now specifically fill in the group name called UV front. And now I could start scaling it to where I would like to have it. And I can also see it's reversed. So that should be, so it should be like this. So it should be something like this in my case. And we can also ask the center of this. You can also ask the center of the object to automatically move this piece around. So in here, we can then ask the center from itself, and I would like to know what the z-axis is in size. So this will automatically place it in the middle of the screen, even if the screen is a different ratio. And lastly, I want to do in the screen is I want to make sure I have a group called screens, where I have filled in this information where all the screens are located. So we'll be copying this group as well here, so I can access this information in a material ID. So if I would scroll down here at the bottom, and we see everything is here combined together, I can now also use the quick material here as well. And in the quick material, we can fill in the screens, so I can color it green. And as you can see here, this is then colored green as a new material ID. One issue left is that this part right here, the UV, the screen with UVs, we probably override these UVs, and I can go up here where I created the screen, and I can start blasting away that screen information. So in here, I should have a group called screens, and I can blast this away, so this is not included in the unwrap anymore. So now that's all set up, and let's test this out in Game Engine. Then here we are in Unity, and I can see I have my digital assets here, and I can drag and drop it in Unity if the plugin is installed. And that should look something like this. And I can already notice that the material is pink. So in Houdini, we can here use the material. So Unity material. So we can fill in the default material that they should be using. So we're going to fill in the pad. So in my case, it's something like this, where I go to the asset folder. I have a folder with my base materials, and I have a base color material. So saving this would help with materials. One little thing I forgot is that in here we deleted the screens because we didn't want to override the unwrap of the screens. So I restored the screens by getting them from the original and then blast away everything else except the screens, and then merge it back here. So we have the screens also here. So let's go back to Unity, and we're gonna click rebuild asset, and if everything is okay, then we should see our material on this. So if you're doing it this way, one thing you should know is that it overrides all my material IDs. So right now I have only one material ID, but in Houdini I made multiple material IDs. As you could see, I had one for my screen, one for the back panel, and one in general. So you have to keep in mind that these nodes will override the other material properties that we have made. So what you could do is you can copy these nodes, and then you can fill in a new material with, for example, here the screens group, and then we can fill in another material for the screens. So this is done for the screens, and we can also here, instead of having these material IDs, we can make a group, and I can save this information in the group. And then same here, I can duplicate this node and then use the back panel group that I just made to assign the material. So let's save this and go back in Game Engine, and I'm gonna rebuild it, and I can see my materials are now assigned. And I already pre-made the screens and the backside, so they're already in place. I made a very simple screen shader in the shader graph, and also this back panel is from the Substance library. So if you're looking for the same panels, then you can go to the Substance Source website and check it out. So further, let's test out some of the parameters and the tools. And as you can see, my tool works pretty well. You can make quick changes. So we can start fine-tuning what it should look like. Or you can always go back in Houdini and make changes if some parts should be better placed. You can, from this point, you can always go back and forward and start tweaking. And I would also love to test out the baker, so we can go here, and we also enable the UVing. This might take some time to calculate. So now the UVing is enabled. So then I fill in the path to save in my render folder over here, and I will be also increasing this to a 2K texture, and we can also set the ray distance, and I will be lowering this. When that's all set up, we can then click bake, and then in a moment we have the texture. So then the baker is done, and if everything is alright, we should see our textures here. If the textures are not showing up immediately, you can always right click and check if they are here in the folder. And then I have here my preview material, so I'm gonna drag the material on here, and I'm gonna assign the normal, and you could see the result. So now I have some round edges around my model. So if I would, for example, lower the normal intensity, then we can immediately see what it is doing, so it helps a lot. I've also baked out a curvature and an ambient occlusion. So in Houdini, if you would go to the baker, I just enabled AO and curvature. And the reason for that is I want to use this then for my texturing. So what I did in this video is I textured it in Substance Painter. So based on the curvature and AO, I can then use this in Painter to start texturing. So how can we bring everything in Substance then? So first of all, you can like bake out your model to a prefab or game object. And then when you drag and drop a model in your scene, you can actually right click export to FBX. So we can import this in Substance Painter, for example. So if I go here, this is an example then textured in Substance Painter. So in Substance Painter, you can then drag and drop the FBX and the textures, and then we can here in the texture set apply, for example, our textures that we baked. So as you can see here, I've called it the tutorial texture. And then for the maps I didn't bake out, I can always here start baking out world space, position, or thickness. So once that's ready, we can then start texturing. And then again, we can go back and forth between Painter and Unity, so we get then to get the final look of the model. That could also be a cool way to work, is that someone who is designing the level, they can like use these digital assets to find out what fits the level the most, and then they can bake the result and give this model and textures to the material and texture artist, who can then create the final look of a prop. So this is then a game ready model. And what we can actually do is we can sort of extract certain pieces for modularity. Like I can use this screen to either add more screens on this tank, for example, or we can also extract one of the tanks and then we can start placing them around as well. So how would you be doing this? So here in Houdini, a way for doing this is we can actually use an FBX node. And in this FBX node, we can actually export an FBX. It's also important to place a null node here, and this will sort of stores the mesh name as well. And then we can export an FBX. So this again can also be used then in the digital asset. So if I would go here, we can then also include export options if you would like that. So we can take the location and export button. So we can, for example, here export screen. So if you're interested in doing that, you can use the FBX node and then export separate pieces. So as you can see here, we have now added this menu to then export a screen. And then you can repeat this process for all the models you would, for example, would like to see. So, and that was it for this tutorial series. I hope you enjoyed it and thank you for watching.